In this lecture, we'll introduce the concept of a set system. A set system is made by a pair. First, you have a set of n elements that is known as the ground set. And then you have a set of subsets of this ground set. For example, if the ground set is 1, 2, 3, and 4, the set of subsets could include the following subsets of X. Next, we need to look at the concept of a restriction. The restriction is defined like this mathematically, but another way of looking at it is like this. For every subset included in S with intersected with A, and the resulting subsets will define the restriction. You can see that these intersections will be, in this example, this empty set, the set 2, and the set 4. Next, we need to look at the concept of a set being shattered. A subset A is shattered if the restriction of S onto A has all possible subsets of A. In our example, A is not shattered because we are missing the subset 2 and 4. The maximum size of a shattered subset is known as the VC dimension of the set system. Note that if this maximum could be arbitrarily large, then we just consider it to be infinite. Let's look at an example. Imagine the ground set is a set of all the points in the plane. The set of subsets is defined as follows. For every half plane, we consider the subset of the plane inside that half plane as an element of S. For this half plane, the subset of the plane in the gray region is an element of S. Now let's look at the concept of restriction. If A is a subset of X with 3 points, P1, P2, and P3, then the restriction will be defined like this. And since A is finite, the restriction will also be a finite set system. Let's look at a few elements of this restriction. By intersecting this half plane with A, we get the empty set. By intersecting this half plane, we get the set P1. We get the set P2 here, P3, P1, P2, and so on. We can get all possible subsets of A. This means A is shattered. If we add one more point to A, then A cannot be shattered. This is because we cannot have a half plane that includes P3 and P4 but avoids P1 and P2. And you can in fact show that no subset of 4 points can be shattered. And thus the maximum size of a shattered subset is 3, and thus the VC dimension is 3. One of the main lemmas here is the shatter function lemma, which says the following. Consider a set system with VC dimension D. For any subset of the ground set N with n elements, the maximum size of the restricted set system is bounded by this formula. We prove this using induction. First, observe that if n is at most d, then this value is at most 2 to the n, or exactly equal to 2 to the n, which is the maximum size of a restricted set system, because a restricted set system could at most include all possible subsets of A. So let's assume the lemma holds for these range of parameters. We'd like to prove it for a subset containing n elements. We could write the subset as some x0 union some other subset containing n-1 elements. Let's look at the restriction of S onto A prime and assume it includes the following subsets. Since A prime has n-1 elements, using the induction hypothesis, we could have this. Now let's count the number of points in the restriction of S onto A. Every subset that is inside the restriction of S onto A must satisfy one of these two conditions. Either it's been obtained from the restriction from some subset in the restriction of S onto A prime, or it was obtained from some subset in this restriction of S onto A prime by adding x1. One of these two cases must hold. Thus, the restriction of S onto A will have at least this many subsets, because for every element of the restriction onto A prime, we will get an element that is inside the restriction of S onto A. However, for some elements, we might get both of them. So in other words, for some subsets Si, both of these conditions could be true, which means we need to add the number of such subsets that satisfy both of these conditions to this value. But how many subsets Si can satisfy both of these conditions? It is easy to see that the set system that is defined by these subsets will have VC dimension d-1. In other words, if we could find a subset that has size d and is shattered, then by adding x0, we could have a subset of size d plus 1 that is shattered. Thus, it follows that the number of the set systems, or the number of subsets that satisfy this branch, is at most this many. By what we argued, adding this, or the number of subsets that satisfy both of them, to this value will be a bound on the maximum size of the restriction of S onto A. This means we'll get the following recursion, and you can easily verify that with our definition of function f, this recursion is satisfied.